All right, welcome back. I'm Thomas Paul, 10 plus years tutoring math and science and unlocking student potential. And we're back with another trig trick. This time we're back on isosceles triangles. And it says here we have two isosceles triangles shown above, or in this case to the side. And it says if 180 degrees minus z equals 2 times y, and y equals 75 degrees, what is the value of x degrees? So we'll begin again. Let's start with some orange today. It's the background we need to know. And we're going to need to know some decent amount of geometry background. So look at number one. We first need to know something about isosceles triangles. By the way, bravo if you can spell isosceles. I had to check. So isosceles triangles, and we need to know about base angle and base angle theorem. And this basically says, let's draw a bigger triangle so we can see it. Pretend this is an isosceles triangle. Well, actually, here we go. So if these two side lengths are the same, that means these two angles are the same. And so you can think of this in terms of if we called both of these angles A, because they're both the same, A degrees, and this last angle was B, then we know that 2 times A degrees plus B degrees equals 180 degrees. This is the first bit of background you need to know. One, that isosceles triangles, through base angle theorem, tell that if we have the same sides, we should have the same angles. And secondly, we need to know that, go to a new color, that the sum of the angles of a triangle, is 180 degrees. And that's how we make this next equation. So basically, if these two angles are the same, we can just put 2 times A plus B, 180 degrees. And that gets us started here about how to attack this problem. So we look at our first bit of equation. We're going to need to solve here. Let's look at solving for Z. So our third thing we need to be able to do, if we switch colors again, let's go to blue, is we need to be able to solve an equation using, and we're going to use in this case, substitution. So let's show that now. Because we have it set up for us already in this set here. So we know 180 degrees minus z, or z, equals 2 times y. But wait a minute, we know y is 75 degrees, so we'll just write 100. Well, that's just 150 degrees, because 75 times 2 is 150. And now we have a new equation here. So let's add z to both sides, and we'll ignore this middle section because we know what y is already. Okay, so we have 180 degrees equals 150 plus z, because our z's canceled out. We subtract 150 from both sides, and we get that z equals 30 degrees. So that's one of our background steps right there, and then we're in the third here. This is going to be a bit of background here, because now we need to apply this to our triangles here. And so let's do a little redraw. It helps us here just to do that. Always be good at drawing your triangles again. So you're not perfect, but it helps us to get a good bit of figure here. We know this is, there we go. Just a quick sketch, because it allows us to do the drawings we need to do. So we know Z right away is 30 degrees in here. Get a piece of paper handy. We know Z is 30 degrees. And let's just use another letter for these. Hey, let's call these both A. That's angle A. That's also angle A. So it means we can solve for this angle here. Because remember, we're looking to solve for angle X here. This is going to help us out. So let's write an equation again. We know that 2 times A plus 30 degrees equals 180 degrees. And you see we're using that background knowledge we had from base angle theorem to set up this new equation. And so we have here, we can solve for A if we subtract 30 degrees from both sides. So it is that 2A equals 150 degrees, and we see that A is going to be 75 degrees. And so we have to add one more thing. get some more paper here. So now we have A. And the fourth thing we need to know, let's go back to orange to cap it off. The fourth thing we need to know is that linear pair angles are supplementary. And this means that angle A plus angle X here equal 180 degrees. That's what supplementary means, 180. So here, we know what A is 75. So we substitute again, plus X is 180. And now we can finally solve for X, because that's what it asked us to solve for way at the beginning of these isosceles triangle problem. So we have now that X degrees is 115 degrees. Whoops, pardon me. 105 degrees. Let's cap that off. Okay. And so let's look at the background here. Problem like this was very challenging because it had to know the background from geometry of isosceles triangles. The two angles are the same, and the vertex angle is different. We had to put that into an equation based upon the sum of all the angles of a triangle, or 180. Then we had to solve an equation using substitution, which they gave us right here, giving us Z. And the trick here, I think the hardest part for students of the SAT, is they had to do it again. So we had to solve an equation using substitution not once, but twice. We solved first for Z doing this way. Then we solved for this angle known as we called it A, which is a linear pair with our angle of interest, angle X. So we had to do this twice, probably 3 times. And so that was the trick with this one. The background knowledge is minimal, but you had to apply it repetitively. Resiliency was the big trick of this problem. Until next time.